All right, let's do some practice with some half-life equations. We're going to start with phosphorus-32, which has a half-life of 14.3 days. How many milligrams of phosphorus-32 will be left after 57.2 days if you start with 4 milligrams of the isotope? So first thing I notice is the 14.3 days and the 57.2 days. So I have 57.2 divided by 14.3. Let's figure out what that is going to calculate out to. That's going to be exactly 4 half-lives. So I know I'm going to start with 4 milligrams, and I'm going to take half of that 4 times. So 4 times 1 half times 1 half times 1 half times 1 half. That is going to work out to be, plug that in, I'm going to get 0.25 milligrams. Another way to do this is take 4 milligrams times 1 half to the 4th power, with 4 representing the number of half-lives that we're talking about. You do that, you're going to actually get the exact same result. So raise that to the 4th power, multiply that by 4, and you get 0.25 milligrams. So let's assume we have a half-life of 1,599 years. How many years will be needed for the decay of 2,587.0 grams of radium-226 to 161.6875 grams? So this one's going to be a little bit different of a principle for how we're going to get to that. We're going to start with 2,587 times 1 half, so let's assume 1 half-life. That's going to give me 1,293.5 grams. Okay, I'm not there yet. Let's multiply it by half again. That's going to get me to 646.75 grams. Still not there. Multiply it by half again. 323.38. Multiply that by half again, and finally now I'm going to get to the 161.6875 grams. So let's take a look at this. I had to multiply it by 1 half 4 times, so that means I'm going to have 4 half-lives. 4 times 1,599 years, which is the half-life of this, is going to give me a total amount of time of 6,396 years. So here I'm just figuring out how many half-lives am I actually talking about right here. All right, half-life of cobalt-60 is 5.27 years, and there's 10 grams left after 52.7 years. How many grams did you start with? Well, I'm going to take 52.7 years and divide that by 5.27, which is a half-life, and that really works out to be 10 half-lives. That's how long it took to get to there. So let's take 10 half-lives, and now we're going to kind of work backward. We're going to double it each time. So 10 times 2 to the 10th, because really I'm doubling it, and now I know I'm going to be doubling it 10 times. I'm going to solve that out. So 2 to the 10th power is going to work out to be 1,024. Take that, multiply it by 10, and I'm going to work out to 10,240 grams. So that's what I started with. All right, so the half-life of polonium-210 is 138.4 days. How many milligrams of polonium-210 would remain after 415.2 days if you start with 2 milligrams of the isotope? So here I'm going to start with 415.2 days, and I'm going to take that and divide that by 138.4 days. That works out to be exactly 3 half-lives. So that's how much was going on there. So I started out with 2 milligrams, and I'm going to figure out, well, I have 2 milligrams, and I'm going to take that times 1 half to the 3rd power, punch that in, and I'm going to be left with 0.125 times 2 is going to work out to be 0.25 milligrams. So that was how much I'm going to have left at the end. Half-life of radon-222 is 3.824 days. After what time will 1/4 of a given amount of radon begin? So I have 3.824 days is going to be 1 half-life, and then another 3.824 days, I'm going to have half of that, so that's me 1 half times 1 half, so I'm going to get 1/4 of the original amount after 2 half-lives, so that's 3.824 days plus 3.824 days, that's going to work out to be 7.648 days. All right, last one. A sample contains 4 milligrams of uranium-238. After 4.46 times 10 to the 9th years, the sample will contain 2 milligrams of uranium-238. What's the half-life? Well, I know that 4 is exactly double of 2, so that's going to be 1 half right there. So I know that, well, that's half of it. That's 1 half-life. The half-life of uranium-238 is 4.46 times 10 to the 9th years.